Hello everyone. So this is a question from NEET 2025. Given below are two statements. Statement 1, like nitrogen that can form ammonia, arsenic can also form arsine. And statement 2 is antimony can't form antimony pentoxide. Okay. And we have to decide which one of them is correct or incorrect. The chapters involved is P block. So regarding statement 1, that is this statement, all the elements of group 15 form volatile trihydrides of the formula EH3. Okay, so very important statement that all elements of group 15, that is nitrogen, phosphorus, arsenic, antimony, bismuth, all of them, they form volatile trihydrates. So by volatile, I mean, something which has very less boiling point. So they form volatile trihydrates of the formula EH3, where E can be obviously, nitrogen. So if E is nitrogen, then the hydride will be having the formula NH3, right? So the name of NH3 is known as ammonia. If E is, phosphorus, then the hydride will be PH3, which is known as phosphine. If E is arsenic, then the hydride is ASH3 and it is known as arsine. If E is antimony, that is SB, the hydride is SbH3 and it is known as stibine. And if E is bismuth, then the hydride will have the formula BiH3 and its name is bismuthine. Okay, so therefore, yes, arsenic does form ASH3, that is arsine. So therefore, statement 1 is correct. Okay, so arsenic does form arsine like nitrogen forms ammonia. Okay, so statement 1 is correct or true. Okay, now coming to statement 2, antimony can't form antimony pentoxide. Okay, so since oxygen is more electronegative than all the group 15 elements, that is, oxygen is more electronegative than nitrogen, phosphorus, arsenic, antimony, bismuth, all of them. So therefore, group 15 elements show positive oxidation states when they form compounds with oxygen. Very important. Okay, so I will write that down. Group 15 elements show positive oxidation states when they form compounds with, oh, because oxygen is more electronegative, so therefore oxygen, in the form of oxides will get the -2 oxidation state, and hence, group 15 have to show positive oxidation states. Okay, on moving down the group, the stability of +5 oxidation state decreases while that of the +3 oxidation state increases due to inert pair effect. Very important statement. Okay, so as we go down the group, stability of +5 decreases and +3 increases. So due to there is something called inert pair effect. So we have to understand what is the meaning of this inert pair effect. Okay, so to understand this, let's see the electronic configuration of all the group 15 elements. Okay, so first one is nitrogen. So nitrogen is 1s2, 2s2, 2p3, right? Next we have phosphorus. Phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. Then we have arsenic. Arsenic is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, then 4s2, 4p3. Okay, then we have antimony. Antimony is 1s2, 2s2, 2p6. then 3s2 3p6 3d10, 4s2 4p6 4d10, and then 5s2 5p3. Cool. And the last one is bismuth. 1s2 2s2 2p6 obviously, 3s2 3p6 3d10, 4s2 4p6 4d10. Also we have 4f14, 5s2 5p6 5d10, 6s2 6p3. Okay, so this is the electronic configuration of all the group 15 element. Okay, so inert pair effect is as we move down the group, so as we go down from nitrogen to bismuth, tendency of s electrons of the valence shell. Okay, s electrons of the valence shell, for example, in nitrogen the valence shell is n is equal to 2, so I'm talking about the 2s electrons. In phosphorus I'm talking about the 3s electrons. In arsenic I'm talking about the 4s electrons. In antimony I'm talking about the 5s electrons. In bismuth I'm talking about the 6s electrons. Okay, so I will underline them. So I will repeat my statement. As we move down the group, tendency of s electrons of the valence shell to participate in bond formation decreases. Okay, so 6s2 finds it very hard to participate in bonding compared to 5s2. 5s2 finds it hard to participate in bonding compared to 4s2. 4s2 it is tough compared to 3s2, and it's the easiest for nitrogen. Okay, so this reluctance of s electrons to participate in bond formation is called inert pair effect. Okay, so I will write that down. Reluctance of the s electrons of valence shell to participate in bond formation, that is known as inert pair effect. Okay, and this happens because of the poor shielding of the valence ns electrons. That is, these guys are very poorly shielded as we go down by the d and f electrons which are present in between. Okay, for example, in bismuth you can see there are d electrons, there are f electrons. These guys, they have very very low shielding, or they are very ineffective in shielding. Okay, so for example, in the case of nitrogen, so let's understand it by a diagram. In the case of nitrogen, um, let's say this is the valence shell s electron, so there is appreciable shielding here, so therefore it this electron does not receive the full power of the nucleus because of the shielding, so there is good shielding here. But as we reach bismuth, so bismuth is a bit bigger in size, and let's say this is the valence s electron, and there are intervening, or there are occurring in between, we have 4f 4d 5f electrons. These guys, they are not good in shielding, due to which the nucleus pulls these electron even more closely, or with a very high attraction, due to which very high amount of energy is required to lose the s electrons in the case of bismuth. Due to which in bismuth it's tough to lose these 6s2 electron, due to which it finds difficult to show the +5 oxidation state, because for +5 we have to lose these three as well as the two 6s2. But due to the poor shielding of 4d 4f 5d, it's tough to lose them. Okay, so therefore the +5 oxidation state of bismuth is less stable than +5 of antimony. That's very obvious, because in bismuth we have the shielding from 4d 4f 5d. Okay, these have very poor shielding compared to antimony. Okay, so I will write down the statement, that is +5 oxidation state of bismuth is less stable than plus 5 of antimony. Right? And it keeps on decreasing, as we have mentioned that the stability of plus 5 decreases, so it's the least stable for bismuth. Okay, and nitrogen also, because of its small size, high electronegativity, and strong tendency to form p pi multiple bonds, it forms a number of oxides, different kinds of oxides. Okay, so therefore I will give you a table of the different kind of oxides that group 15 elements form. Okay, so let's say the first column consists of oxidation state of element. Then we have oxides of nitrogen. Then we have oxides of phosphorus. Then oxides of arsenic. Oxides of antimony, and last oxides of bismuth. Okay, so the oxidation state of element when it is plus 1, so nitrogen forms N2O, which is nitrous oxide. None of the other elements in group 15 forms oxide in which their oxidation state is plus 1. Okay, so therefore none of them will form an oxide in plus 1 oxidation state. In the plus 2 oxidation state of the element, again nitrogen forms, because of its small size, high electronegativity, and ability to form p pi multiple bonds. So it does form NO, and none of the other elements form any oxides with oxidation state plus 2. Then coming to plus 3. In plus 3, yes, so we have N2O3, which is known as dinitrogen trioxide. Then we have P4O6, which is our phosphorus trioxide. Then we have AS4O6, which is arsenic trioxide. Antimony does form Sb4O6, antimony trioxide. Bismuth also forms Bi2O3, that is bismuth trioxide. So all of them forms oxide with oxidation state plus 3. Oxidation state plus 4. Again, nitrogen does form, it forms N2O4, which is dinitrogen tetroxide. Then phosphorus forms P4O8, which is phosphorus tetroxide. And none of the other elements form oxides having oxidation state plus 4. Then we have the last one, that is plus 5. In plus 5, nitrogen forms N2O5, which is dinitrogen pentoxide. Phosphorus forms P4O10, which is phosphorus pentoxide. Arsenic forms As4O10, which is arsenic pentoxide. Antimony forms Sb4O10, which is antimony pentoxide. And bismuth does not form oxide in the oxidation state of plus 5, because as I have mentioned that down the group stability of plus 5 decreases. So therefore when we go from nitrogen to bismuth, the ability to show plus 5 decreases. So therefore bismuth doesn't form any oxide with oxidation state plus 5. So therefore it does not form any oxide here. Okay, so therefore our statement 2 talks about the whether antimony forms antimony pentoxide or not. Yes, it does form antimony pentoxide, although it will be less stable compared to the other pentoxides. Okay, so therefore statement 2 is saying that antimony can't form antimony pentoxide. No, this is incorrect. Antimony can form antimony pentoxide, so therefore this is a false statement. So therefore statement 1 is true and statement 2 is false. Okay,